Okay, I have decided to put a video together for some of the Algebra 1 classes that have missed class today because of a basketball tournament that is here at the school. So we're reviewing for a test that's going to be tomorrow, test date 12/5/2014, December the 5th, on Friday. Again, this is for some of the students that were missing the class, and that way they'll have an opportunity to see the review and see how to work each one of the problems. There is a formula chart that goes along with this review that the students should have. They picked up in class. Otherwise, they can Google some of the formulas as needed throughout the video. I will move rather quickly through the video because you'll have the ability to stop, pause, rewind as needed. So I'm going to go ahead and move through it pretty fast. That way we can keep the video itself pretty short. Okay, so starting out, we're going to translate each verbal expression into an algebraic expression. The first one is 5 less than a number. A number we just represent by an X or a Y or a or N, whatever variable letter they choose is fine. But we're doing 5 less than that number, so we're actually having to get smaller than X. In that case, the correct way to write this would be X minus 5, because we're getting smaller than a number and we're getting smaller by the increment of 5. Number 2, almost the same type question here. 4 less than 1/2 a number. We're getting smaller than 1/2 of a number. So 1/2 of a number. And we are going to take 4 away from that because that's how much we are getting smaller than half of a number. And that's simply all you have to do on these. We're not actually solving for X. We're just writing the expression. Number 3, 2 times the sum of a number and 6. Anytime we see the sum of, we know we're going to have to use parentheses because sum of means we'll have to do an addition. So we're going to have a number added to 6. We're going to multiply 2 times this sum. So we put parentheses around it, we put a 2 in the front, and now we have 2 times the sum of X plus 6. Number 4 is 7 decreased by twice a number. Now, when we say decreased, we're actually taking away from whatever's in front of decreased. And so you can write this in the normal order. 7 decreased, or subtract, by twice a number. And twice just means 2 times our X, or whatever variable you've chosen to represent a number. Okay. We're going to move along to translating and solving. So we're going to move up or down the page here. We're going to go to number 5. On number 5 here it says, if negative 15 is subtracted from 3 times a number, the result is 45. What is the number? Anytime they give you a negative number and you're trying to rewrite this in an algebraic expression, put that number inside parentheses, and that will help keep your signs correct. So we've got negative 15. We're subtracting this from 3 times the number. So we're taking this away from 3 times a number. All right? And then the result, of course, is just equals 45. Now it's asking what is the number. So we've written the expression. We're going to solve for the number. We've learned through previous lessons that anytime we have subtracting a negative, it just means positive or addition. So we will rewrite this as 3x plus 15. That's going to equal 45. And now we need to solve for x, and we do that by getting rid of the 15 first. We will undo addition. So we will take 15 away from both sides. This 15 will cancel as it becomes a 0. This will become 30. We'll rewrite this over here to the side. 3x is what's left on the left side. On the right side we have 30. And now we need to solve for x. And we have 3 multiplied times x. We undo multiplication by division. So we divide by 3. And of course we divide the other side by 3. And the 3's cancel this side, leaving us x. 30 divided by 3 will give us 10. So our answer will be x equal to 10. Okay, moving to number 6. Number 6 says 5 more than. Anytime you see more than, this is an addition problem. Addition does not require us to keep everything in a certain order, so we can just write it as we see it. 5 more than 6 times a number is just means equals, and 77 is our answer. Find the number. So again, we're going to have to solve for x. We have 5 added to 6x. We take 5 away from both sides. Our 5's cancel because they become 0. Leaves us with 6x on the left side. On the right side, we are left with 77 minus 5, which is 72. So then we solve for x. In this case, 6 is multiplied times x. We undo multiplication by division. Divide by 6. Divide by 6. The 6's go away. X is equal to 12. That is our answer for number 6. The next section here is solving the variables indicated. This is our literal equations section. And in this case, we're not going to come up with a value, an actual numeric value. We're just going to come up with representations of how we would solve for the variable indicated once we get that variable by itself on one side of the equal sign. So in the first case, we're solving for s. And the way we would solve for s in this case, we would divide by 2 on both sides. And therefore, s would be equal to p over 2. And that is our answer. We leave it in this form. Number 8, we are solving for a. D is equal to AB divided by 2. The first thing we would normally do in this case here is we would get rid of our 2 in the denominator. If we're dividing by 2, we want to undo that. We would multiply by 2. And if we do it on this side, we have to multiply by 2 on the other side. This will give us 2D equal to A times B, because these 2's will cancel, become 1. Now we solve for A again. On this side here, we just simply divide by B, divide by B. The B's will cancel. A will be equal to 2D over B. And again, this form is the way we would leave our answer. Number 9, last one on this page, we're solving for y. We have 4x plus 5y is equal to 8. So we need to get the y term by itself. The first thing we'll need to do is get rid of our 4x. It's added to 5y, so we subtract 4x, and we have to do that to both sides. 4x's will become 0. They'll cancel. That leaves us with 5y equal to, our 8 and 4x can't be combined because they're not in the same family. So not in the x family. One's the x family, one's just an integer. So we'll have to leave it as 8 minus 4x. Now we still have to get y by itself. We undo the multiplication of 5 times y by dividing by 5, and we'll divide by 5 on this side as well. 5's will go away. Y will be equal to 8 minus 4x over 5. Again, leave the answer in this form. And that is the answer for number 9. On the back, we will move into our formula section. On the formula section, again, you will have a formula chart to use on the test, and we should have formula charts in our papers that we've picked up over the last couple days here to reference for doing homework and this review. Find the area of a trapezoid if the height is 10 centimeters and the lengths of the bases are 20 centimeters and 10 centimeters. The area of a trapezoid we can find on our formula chart, or obviously you can Google it as well. Area of a trapezoid is going to be 1/2 of base 1 plus base 2 times the height. And as we've been doing on all of our formula problems, We create a key on the right side over here, and we begin to list what the actual question gives us for some of our values. We know the h height is 10 centimeters. We know that the bases, base 1 and base 2, doesn't matter the order. Base 1 is 20 centimeters, base 2 is 10 centimeters. The area is what we're trying to find. And then we simply take our key, plug those values into our formula, and solve for the unknown. In this case, again, A is our unknown. It's going to be equal to 1/2. Base 1 is 20 plus base 2, which is 10, all times the height, which is also 10. So we have area is equal to 1/2 of 30 times 10, and half of 30 is 15, and 10 is going to make this equal to 150. This is centimeters squared. So area is going to be equal to 1/2 of 30 times 10, which will then again equal 150 centimeters squared. Okay. That should be our area for the trapezoid. On to number 11. Number 11, we have the width. We're trying to find the width of a rectangle if the perimeter is 54 centimeters and the length of the rectangle is 11 centimeters. We wrote this down in our formula chart. It wasn't listed, but we wrote this down in our formula chart that the perimeter of a rectangle is equal to 2L plus 2W. We can derive that formula pretty easily just by drawing our rectangle. We have 2 L's on each side and 2 W's, and if we add all those up together to find a perimeter, we come up with the formula P equals 2L plus 2W. We create our key on the right here. P is actually known, and that is 54 centimeters. The length is 11 centimeters. The width is our unknown in this case. So we plug our values into our formula. We have 54 is equal to 2 times 11, which is L, plus 2W. Obviously, 2 times 11 is going to be equal to 22, plus 2W. Again, this all still equals 54. We will subtract 22 from both sides to isolate our 2W. Subtract 22. Our 22s on this side will cancel. We'll move this all over to this side over here. 2W will be equal to 32. When we subtract 22 from 54, we'll get 32. Divide by 2, divide by 2. W, running out of space here, W will be equal to 16, and of course that's also centimeters. Ran out of room just a little bit there, but you can see the answer, 16 centimeters. Number 12, find the area of a circle if the radius is 6 inches. We're going to use 3.14 for pi. Sometimes we'll leave pi as just the symbol pi, and we'll leave the answer in terms of pi, but in this case they want us to substitute the value of pi as 3.14. So the area of a circle is pi r squared. Draw our key to the right. We have radius is equal to 6 inches. Pi is going to be equal to 3.14 as they gave us. So we'll substitute those into the equation. Area is going to be equal to 3.14 times the radius, which is 6 squared. And if you put this in your calculator, area will end up equaling, I believe it is 113.04, and this is going to be in inches squared. You may see on the test where they'll ask you to round that to a certain number of decimal places. In this case, we're just going to leave it as is. Number 13. Number 13, find the lateral surface area of a cylinder if the radius is 4 centimeters and the height is 16 centimeters. This time they want us to leave our answer in terms of pi. So we won't give pi a value. We'll just leave pi in the formula or in the answer itself. When we look at our formula chart, be sure you remember that this is lateral surface area, not total. So we find surface area, we go to cylinder, and then we look over in the column for lateral. Lateral surface area, formula should be 2 pi r times h. Draw our key to the right here. We know the radius is equal to 4, the height is equal to 16, and we don't know what the surface area actually is. Pi is going to remain the pi symbol. We plug in our values here. S is going to be equal to 2 pi, r is 4, and h is 6. When we multiply all these together, 2 times 4 is 16. H is 16. 2 times 4 times 16 should give us 128. Still multiplied times pi. And this was in centimeters squared, so that is our lateral surface area of a cylinder. 2 pi times 4 times 16 will equal 128 pi centimeters squared. Alright, the last two problems on our review are actually review problems from previous chapters, previous sections. The first one, we're going to solve a percentage problem, and that is John took $200 with him to Bass Pro Shop to spend on hunting clothes and equipment. He spent 20% of his money on clothes. How much did he spend? We have a few different ways you could write this out, but the simplest way that we found to remember is just take your 20 or your percentage, take your percentage, multiply it times the amount, which is 200, divide the whole thing by 100, and you should come up with your answer of $40. And that is 20% of 200. He spent $40 on clothes at Bass Pro Shop. Last one, we have set up a proportion and solve. And this is a problem that you're going to be familiar with. We've seen this on the test before, and you're going to see one like it again on your test tomorrow. A model airplane is made up of the scale 1 to 24. We can write 1 to 24 as 1 over 24. This is a proportion, so we have this ratio that's going to be equal to another ratio. The wing size of the full-size plane is 18 feet. How long would the model wing be in inches? Alright, well, the key here that several people missed last time was that this is 18 feet, and we need that to be in inches. So we'll have to multiply 18 times 12, which is the amount of inches per foot. Should come up with 216 inches. Now that's how long the actual plane's wing is. We have the model size over the actual size here on this side of the ratio. We want to put the model size, which is what it's asking. The model size, we don't know, we'll use X, over the actual, which is 216. Model over actual, model over actual. It's a proportion, so we know the property of cross multiplication, or the cross product, will be equal, so we can cross multiply, set it equal to each other, solve for X. 24X will equal 216, which is 216 times 1. 24X divided by 24, divide by 24. 24s will cancel here. X will be equal to 9, and this is in inches. So the model plane's wing will be 9 inches long. This concludes the review. We do have a few more questions on the test, a couple more questions on the test that will be involving direct and inverse variations, but we will give you the general equation for those on the board when we take the test, and you can study your papers that we have worked on from the past on direct and inverse variations. Thank you.